Hello, sixth graders. We are going to begin today a lab about Newton's first law, and it's called Sudden Stops Hurt. So it's kind of around the whole idea of seatbelts and Newton's first law. Okay, so your background information says that Newton's first law describes motion and the acceleration of objects. There are two parts to the law. The first part says that an object at rest will stay at rest. The second part says that an object in motion will stay in motion. Both parts of the law have an addition that say, unless acted upon by an unbalanced force. Tying together what we've learned so far about velocity and acceleration, look at the diagram to the right. Another way of looking at this law is to say that objects won't accelerate unless they are acted on by an unbalanced force. That means if I have this little race car on my hand, it's going to stay at rest unless it is acted on by an unbalanced force, which would be me pushing it, or it being on a slope and then gravity and friction working on it, okay? So it says, can an object in motion have an acceleration of 0? If so, how? And we're going to go over, I'll make another video about these questions, okay? So for right now, and if you're a distance learner, you can either edit this, this PDF, or you can just make a Google Doc and number them, maybe give them the header pre-lab questions so that I know what you're answering. This is just, what do you think right now? Can an object in motion have an acceleration of 0? If so, how? In a car crash, there are two collisions. The first one is when the car runs into the other car. What do you think the second collision is? Hint, it's the one that hurts. Okay? Refer to the picture at the right. The car is about to run into a wall. Make a prediction about what will happen to the car and what will happen to the person. Okay, in the car, your prediction is the car will what? And the person in the car will do what? Okay, today a big part of this is going to be setting up this lab. And if you are a distance learner, you can use just about anything around the house that will make some sort of a ramp, and anything that will move down the ramp without falling off the edges. Okay? So if you've got meter sticks, great. If you've got a yardstick, great. If you just have a board, great. That's just fine. Any sort of thing that will make a ramp that's about a yard long or about a meter long. All right, now the other tricky part that we're going to be working on today is to make kind of some guardrails on the side of it so that the car, as we push it down, and when I say car, I mean a Hot Wheels car. And again, if you're a distance learner, you could use a marble. You can use anything that will slide down the ramp. We don't want it to fly off the edge, okay? And so what we're going to do today, and today you guys can, if you're a distance learner, just work on making some kind of a ramp. I've taped these two meter sticks together. Here, let me go to full screen here. There we go. All right, so I've taped these two meter sticks together, and I used a minimum amount of tape, okay? Because we don't want to have so much tape on the ramp that it creates more friction. We don't want it to have a big bump that the car will encounter, okay? So as the least amount of tape as possible to tightly tape these two together. And I did that because some of these cars are a little bit wider than 1 meter stick. You don't have to do that if you've got some other idea for a ramp at home. Then we have little drinking straws. And what I've done here is I've taped the drinking straws along the edge without getting any tape on the meter sticks themselves, okay? So if you look right here on this side here, I just have some tape wrapped around the bottom, and it wrapped around the outside edge of the straws to hold them in place. And that just makes a ramp that the car will go down, and if it kind of goes off to one of the sides, it's going to bounce back in, okay? And our idea today is to just kind of test it out to see if we can get a car to go down the ramp with, and I'm going to use a little tiny bit of clay. I'm going to put that on top of the car. and I'm going to put a penny on top of it. Now, I don't want to push the penny down. That clay is just there to keep it from falling off the car before it gets down to the end of the ramp. Okay, so I'm going to send this car down the ramp, and it's going to get to the end, and I'm going to set up something, anything that you've got, your iPad, a phone, that's going to stop the car in its tracks. Okay, so you're kind of creating a wall, but you don't want the wall to be so tall that the penny, when it flies off, hits the wall. Okay, so you've got to have the wall low enough to stop the car, but allow the penny to fly forward. All right. The other part of the lab then, go back to the sheet. The other part of the lab then is going to be to take some trials, okay? So we are going to be releasing the car at these different distances, okay? So the first time we release it, we're going to release it from the 10 centimeter mark, meaning it's going to be really close to the end. It's going to be really close to the end. And then we are measuring, when the car stops, how far does the penny fly from the end of the meter stick out onto the table. Okay, we're going to do that 3 times successfully. So if your penny falls off or whatever, you know, those are that's a little bit of experimental error, so you can try again. Do 3 good trials and measure the distance that the penny flew from the edge of the meter sticks out. Okay, then we're going to do the same thing, but we're going to release the car a little bit further up. Do that 3 times. Take an average. 30 centimeters, 40 centimeters, and then finally 55 centimeters to see how far the penny will fly and kind of investigate the relationship between the distance we drop the car from up the meter stick to how far the penny flies. Again, if you're working at home and you don't have meter sticks like this, you can just measure it with a tape measure. You know, measure 10 centimeters up your ramp, 20 centimeters up your ramp, 30, 40, and 55, and then also measure how far the penny flies forward. All right? Again, today, just work on making a ramp and figuring out what kind of wall you need to stop the car and allow the penny to fly forward. All right? Tomorrow we can really work on collecting that data. We just want to get a functioning ramp, a functioning wall for allowing for that penny to fly forward. Okay, and we will do a little bit of the trials tomorrow, and I'll make another video. I'll talk to you soon.